Hello and welcome to another episode of Astronomy Answered Simply. Today I'm filming in front of my live studio audience. Say hello, live studio audience.
Hi.
Dresden, say hi.
Hi.
It's challenging in front of a live studio audience. So, today's question is, we have been able to travel to Mars since the late 1960s. What's the problem with going there? Well, first, let's discuss how successful we've been since the 1960s. About half the probes that have been sent to Mars have crashed and failed and lost contact on the way. Hey, live studio audience member number one, would you please put the glass object safely back on the shelf? Thank you. Thank you. So, we don't have the highest success rate of getting robots to Mars. Now, every mission we've sent to Mars has been robotic in nature. We send robots. Why? Because robots don't require food, air, water, atmosphere, little pesky things that we humans require every day. Gravity. Robots don't care if they're in microgravity or zero gravity. They still function just the same. Humans, on long duration spaceflight, we lose bone density, we lose muscle mass, and it can be problematic. So we need to at least create some form of gravity while we're traveling. So travel to Mars is difficult. Just getting to Mars is like a 3 to 6 month journey, depending on the alignment of the planets, the speed, lots of different variables. But if we were basically sending a mission to Mars, we're looking at a roughly 18 to 24 months round trip. A year and a half to 2 years, 2.25 years a round trip time, depending on launch windows and orbital mechanics of such, and allowing time for errors and problems which occur. So you have to plan for the longest period of time and then some, and you're not able to resupply. So you have to bring all the food, all the oxygen, all the air, all the water you need in advance, because there's none on Mars. There's no food, there's no water, there's no fuel. We don't have anything set up there. There's no infrastructure. When we sent people to the moon, we used giant spacecraft to launch a much smaller spacecraft, and then the only part of the spacecraft that returned was a tiny fraction of what we sent there, because of trying to bring the minimum amount of mass back. We left tons and tons and tons of stuff behind. Like the lunar rovers, the landers, the only thing that came back was that one little tiny module with just enough fuel to get it back into orbit around the moon and sync up with the command module in space to bring it back to Earth. And then even then, some of that was discarded en route back to Earth, and only the capsule came back to Earth safely. The rest of it burned up in the atmosphere. So thinking about a trip to Mars, even if we were to use something like a SpaceX or Boeing, Orion capsule or SpaceX's Space Starship 1 or whatever it's going to be called, you still got to have a lot of equipment in advance and a lot of infrastructure, and whole rockets need to be sent there to be able to get people to and from the surface safely. So there's a lot of things that need to happen in order to make it safe and possible, and engineering wise. Watch your fingers, Penny. There we go. The engineering aspects of going to Mars are the problems. I mean, in theory, we know how to do it. We know we're capable of it, but we've never successfully engineered the equipment to do this. So it's really a huge engineering challenge to overcome. Not necessarily so much of a scientific one, but even the engineering can be problematic, because until you actually do it, you don't know whether you will be 100% successful. And let's face it, if you're going to be spending 2 years in a tin can, with nothing between you and a solar flare, you want to be pretty sure that your engineering is solid and good and safe and reliable. Even if you're going on a one-way trip, that means you need to send a huge advanced fleet of equipment to Mars. And it all has to land in the same area, and it all has to be functional. You would need functional greenhouses set up. You would need a fleet of robots setting up and connecting generators and infrastructure and lots, say, wind turbines, solar panels, habitats, greenhouses, all would need to be set up if you're going to try and actually live on Mars. Because, again, the atmosphere is too thin and there's no oxygen. The only way we could get oxygen on Mars is if we were able to safely and successfully harvest water from subsurface lakes or from the ice caps, and then electrolyze the water using solar power or wind power to split the oxygen and hydrogen into elemental components and then use that oxygen to create atmosphere. And then I'm not even sure, we would probably have to bring nitrogen as well, just in order for us to be able to breathe, because we breathe 80% nitrogen, 20% oxygen, roughly, 18 to 20% in the atmosphere. Mars is mostly carbon dioxide. So there's a huge amount of engineering challenges that have to be overcome in order for humans to go to Mars. Sending robots, yeah, we can do that pretty easily. We've been very successful in our last several attempts at sending robots to Mars. So, but sending humans, whole different ballgame, whole different set of engineering challenges. That's it for today's episode. Thank you for bearing with me and my live studio audience distractions. And I hope you have a great day. Keep asking questions.